Sup guys, welcome back. So today we're going to be doing some trig equations. We're just going to be doing some basic ones and they're all going to be within the domain of 0 to 2 pi. So let's get into it. All right, so here's the first question. It says cos x is equal to root 3 on 2 and we want to solve between this domain. Now straight away, right, I can see that cos is equal to a positive number. So I'm going to draw out my all stations to central and I'm just going to check which quadrants cos is positive in. So cos is positive in the first, because that's all, and obviously in the cos quadrant. So I tick those to start off with. Now, when I see the numbers root 3 and 2, automatically I should think of my exact value triangles, like this. Now, when does cos x equal to adjacent over hypotenuse? Let me just put in the numbers here. So that's pi on 3, 60 degrees, and pi on 6, which is 30 degrees. Okay, so when does cos give me adjacent over hypotenuse? That must be pi on 6, right? Adjacent over hypotenuse. So x is equal to pi on 6. All right, now what I do from here is I just put in that angle inside my quadrant, so my first one, and also my fourth one. Should be 6, not 4. Okay, because cos is positive in those two quadrants. So I can see that within this 0, pi, and 2 pi, there are going to be two solutions. So what I'm going to do is I'm going to write 0 to represent that start. Now this is pi, but since the denominator's in 6, I'm going to write this as 6 pi on 6. And then all the way around, I'm going to add another 6 pi because that's halfway and then halfway again. So that is going to be 12 pi on 6. And that just helps me work out those numbers. Okay, so my first solution is pi on 6, and my second solution is going to be 12 pi on 6 minus pi on 6. So that is 11 pi on 6. Okay, done. Okay, here's the next example. Solve tan x is equal to 1. So once again, let's start off by doing all stations to central and just ticking which ones tan is positive in. So here it's positive in the first and the third. When does tan x equal 1? So this will also be one of these triangles, but this time it's the isosceles. So tan x equals to 1, so opposite over adjacent, so that's going to be pi on 4. So x is equal to pi on 4. And I put that in my quadrant diagram. Okay, so now that I've put it in, I just put in my value, so 0. Now this is normally pi because since we have a denominator of 4, we're going to go 4 pi on 4, and then this will be 8 pi on 4.
Oh.
Okay, so my first solution is pi on 4, I got that there. And my second solution is going to be 4 pi on 4 plus pi on 4. So that is going to be 5 pi on 4. Okay, done. All right, solve sine x is equal to -1. Now we're going to start by also doing this, all stations to central, but this time we've got a negative value. So when is sine x a negative number? Well, it's going to be the third quadrant and the fourth quadrant. Okay. Now, -1 for sine is slightly different. It's not going to be one of the triangles. Instead, it's going to be what we call a boundary angle. So you need to know the graph of sine. So sine looks like this between -1 and 1. That's 0. That point's pi, that's 3 pi on 2, and that bit's 2 pi. So when does this graph equal -1? So you can see if I draw a line across, it reaches at this point here. That's 3 pi on 2. So x is just going to be 3 pi on 2. Okay, so we've only got one solution here. So in other words, it's just right there. So in fact, you don't even need the quadrant for this one, but it just helps when you're trying to do these questions. All right, so here's the tricky one. 4 cos squared x minus 3 equals 0. Now what you want to do is just solve it like a normal equation where you can. So move the 3 over. So 4 cos squared x is equal to 3. Divide both sides by 4. Cos squared x is equal to 3/4. Now you want to get rid of the squared. So square root both sides will just be cos x. Square root of 3 over square root of 4. So that's just going to be square root of 3 over 2. Okay? But because we square rooted it, you're going to have a plus and a minus. So both positive and negative. All right, once I've done this, draw up my quadrants, all stations to central. And you can see that because it's positive and negative, it's actually going to be all 4 quadrants. Okay? Because it's positive and negative, it's going to be in all 4 quadrants. So when does cos x give me root 3 on 2? So once again, draw out a triangle. Pi on 3 at the bottom, pi on 6. So cos to give me root 3 on 2 is going to be pi on 6, adjacent over hypotenuse. So let's start by writing x is equal to pi on 6. Okay, so I want to put in all my values. So here I've got pi on 6, pi on 6, pi on 6, and pi on 6. And I need to include all those solutions. Now here's where it really helps just to put your values in going around the circle. So 0. Now this is normally pi, but because we have a denominator of 6, I'm going to make it 6 pi on 6. And then all the way around the revolution will be 12 pi on 6. Okay, so my first solution, I've got that there, pi on 6. My second solution will be 6 pi on 6 minus pi on 6, which will be 5 pi on 6. My next one will be 6 pi on 6 plus pi on 6, which will be 7 pi on 6. And then lastly, you've got 12 pi on 6, and you want to take it back pi on 6. So that's going to be 11 pi on 6. Okay, then you're done. All right, thanks for watching this video. If you have any questions, let me know in the comments below. But otherwise, I'll see you in the next one.